Alright, welcome back to another episode. Right. Whew, this is a lot of work, but I know I will be able to finish it before midnight. I apologize deeply again, Mr. Joe. I am very bad at maintaining my time. This is why I'm not good at time. In this episode, we will be mentioning Charles' Law. Last episode, we mentioned Boyle's Law. And so, yes. Excuse me for a moment. I'll just have a sip of water. Alright, excuse me. Okay, Charles' Law. Phew, it's the relationship between volume and temperature, keeping the pressure constant, was also studied. In 1787, French scientist J. Charles presented his law. The volume of a given mass of a gas is directly proportional to the absolute temperature if the pressure is kept constant. So the constant for Boyle's law is temperature, and the constant for Charles' law is pressure. When pressure, aka P, is constant, the volume, aka V, of a given mass of a gas is is proportional to absolute temperature, or T. Okay. Right. If temperature of the gas is increased, the volume also increases. Hmm. Okay. Experimental verification of Charles's law. I didn't read the Boyle's law because it was um, difficult to explain. Okay, number one it takes a certain amount of gas enclosed in a cylinder having a movable piston. Number three, the increase in temperature increases the volume that can be observed. I'm sorry for my laptop moving so much. And whenever you're computing for temperature, I think, always remember this, always convert temperature scale from degrees Celsius to Kelvin scale while solving your problems. And yes, K equals 273 plus the degrees Celsius, and vice versa. Right. Um, there was a lot of computation during that lecture period. Um, excuse the background. Mm-hmm. Okay, so we're gonna be in the next topic. I hope it's enough for 10. Liquid state. It has definite volume, but their shape is not definite. Right. A liquid state attains shape of a container in which it is put. Like water, as you can see, whenever you pour water into a glass, or you pour water into a basin or a container, or like a pot. That's how you know about its depth. And its typical properties. Evaporation, the process of changing a liquid into a gas phase. That's the meaning of evaporation. If you don't know, it is reversed to condensation, which a gas changes into a liquid. And an endothermic process, it's an endothermic process, which means heat is absorbed. In liquid state, molecules are in a continuous state of motion. They possess kinetic energy, but all the molecules do not have the same kinetic energy. Well, a majority have average kinetic energy. A few more than average kinetic energy overcome the attractive forces among the molecules and escape the surface, which is evaporation. Evaporation is a continuous process taking place at all temperatures. It is the rate of evaporation is directly proportional to temperature, and it increases with the increase in temperature because of increase in kinetic energy of molecules. That was a lot. I'm gonna continue this for the next episode because I'm running out of time for the video. Anyway, see ya.